So suppose you have 2 distinct boxes and 4 identical balls. Then how many ways are there to distribute the balls into the boxes, given that no box can be empty? So we have to remember that, given that no box can be empty. So first let's draw out the 2 distinct boxes, and let's label them A and B because they're distinct. And then we're gonna have our 4 identical balls. Let's put that in red. Okay. So no box can be empty. So we can have 1 ball in box A and then 3 balls in box B. Or we can have 2 balls in each of the boxes and have 3 balls in A and 1 ball in B. So there are a total of 3 ways to distribute 4 identical balls into 2 distinct boxes, given that no box can be empty. Sweet. But there must be a better way to solve this problem without bashing it. So actually there's a formula that can give you the answer to this question pretty quickly. And so the formula is that given that no box can be empty, the number of ways to distribute n identical balls into r distinct boxes is m minus 1, choose r minus 1. This formula looks pretty simple, but why does it give that answer? So let's try it out. So let's say that n is equal to 5 and r is equal to 4. So there's 5 identical balls and 4 distinct boxes. So let's draw out our 5 identical balls. And we're going to use dividers to divide these 5 balls into 4 groups. So we have to use dividers. And if we're going to use these dividers to distribute these balls into 4 groups, we're going to need r minus 1. We're going to need r minus 1 dividers. We're going to need r minus 1 dividers. So in this case, r is equal to 4, so we're going to need 3 dividers. Wait a sec. Okay, I'm back. So we're going to use 3 dividers to divide these 5 balls into 4 groups. So we can go like that. If we go like that, then there's 1 ball in the first box, 2 balls in the second box, and 1 ball in each of the third box and fourth box. Neat. But can we have more than 2 dividers between 2 balls in the slot between the 2 balls, in between 2 balls? So let's draw out our 5 balls again. If we have more than one divider in between 2 balls, then it means that a box is gonna be empty. So, and that doesn't meet the restrictions. So no, that does not work. That does not work. So how do we find the number? So basically, we just have to find the number of ways to distribute these r minus 1 dividers among the intervals between the 5 balls. Oh yeah, one more thing. If we have 5 balls and then if one of these dividers is on the side, if it's not between 2 balls, then it means that the first box is empty. And if we put it here, then it means that the last box is empty. So yeah, we can only put the dividers. So the restriction here is that there can only be 1 divider in each of the intervals between 2 balls, and it has to be between 2 balls. It can't be in front of a ball. It can't be not between 2 balls. So you got the basic idea. So then how do we find the number of ways to put these dividers between the balls? So we can just consider that. Let's draw our balls again. So we can just consider that there are slots between the balls, and we're gonna be choosing r minus 1 slots for these dividers to possess. And there are n, and these are the intervals between the n balls. So there's n minus 1 slots. So we're choosing r minus 1 slots among these n minus 1 slots for the dividers to possess, which will be equal to n minus 1 choose r minus 1. And that's our formula. We got a formula. So let's try using this to find the answer to this question. So here n is equal to 4 and r is equal to 2. So our answer will be 4 minus 1 choose 2 minus 1, which is equal to 3 choose 1, which is equal to 3. And that's our answer. And we can see that it's exactly the same to the answer we got by bashing, but this was a much quicker and elegant solution. So remember this formula, it's pretty useful. So this time I'm going to be teaching you a new formula. So let's erase this first. And we're going to leave this diagram here because we're going to need it. So this time we're not going to have a restriction. So any box can be empty. So how would this change the problem? So this time either box A or box B can be empty. So we can have 0 balls in A and have 4 balls in B. Or have 0 balls in B and have 4 balls in A. So we got 2 more ways to distribute these balls. So we have a total of 5 ways to distribute 4 identical balls into 2 distinct boxes with no restrictions. But again, there is a formula that will make solving this problem really easy. And that formula is that given that any box can be empty and there are no restrictions, the number of ways to distribute n identical balls into r distinct boxes is n plus r minus 1 choose r minus 1. A bit more complicated than the previous formula. But how does this simple formula give the answer to this problem? So again, let's say that n is equal to 5 and r is equal to 4. So we're gonna have our 5 balls here again. And again, this time we're gonna have our r minus 1 dividers to divide these balls into r groups. So here we're gonna have 3 dividers because r is equal to 4. So this time any box can be empty, so we can actually have more than one divider in between 2 balls. So we can have it like that, or we can have it like that. Yeah, we can have it not between 2 balls. So we can actually put these dividers anywhere because there are no restrictions. So we can put it like that. So if you keep going, you're gonna notice that basically we're just looking for the number of ways to put these n balls and r minus 1 dividers in a line. So we're just finding the number permutations of these n balls and r minus 1 dividers. So we can easily find that value using permutations. So we have a total of n balls and r minus 1 dividers. So we have a total of n plus, we have a total of n plus r minus 1 objects. So n plus r minus 1 factorial divided by, and there are n identical balls, so we have to divide by n factorial. And also the r minus 1 dividers are identical, so divide by r minus 1 factorial. So that's our formula, but what is this equal to? Well, n plus r minus 1 is equal to that, so basically this is just n plus r minus 1 choose r minus 1. Neat, we got our formula. So we can just plug in these values into this formula to quickly get our answer. So here, for n is equal to 4 and r is equal to 2. So the formula gives us that 4 plus 2 minus 1, choose, this is equal to 4 plus 2 minus 1, choose 2 minus 1, which is equal to 5, choose 1, which is equal to 5. So there are 5 ways to distribute 4 identical balls into 2 distinct boxes, given no restrictions. And turns out that that's the answer that we got previously. So we got our answer right. So this time again, this was much more quicker than just bashing it out and finding all the ways to like find the number of ways to distribute the balls. So this formula and the previous formula is actually pretty useful in these kind of questions. So let's review our formulas then. So erase this all. Whoop. So if the question says that no box can be empty, so we have to distribute n identical balls into r distinct boxes, given that no box can be empty, then the number of ways to distribute the balls into the boxes will be n minus 1, choose r minus 1. And if the question says there are no restrictions, so the boxes can be empty, then the number of ways to distribute n identical balls into r distinct boxes will be n plus r minus 1, choose r minus 1. Neat. So those are the formulas that you must remember to master those combinatorics problems. So yeah, so if the problem is about like distributing balls into boxes, then these formulas will come pretty handy. But in the next video, I'm going to be teaching you how these formulas can be pretty innovatively used in math problems. So the problems are not going to be directly about distributing balls into boxes, but like you have to think about it a bit metaphorically, not really. Like you have to think of it in a different way in order to use these formulas. It's pretty fun. So hope you understood this video and remember these formulas. And see you in the next video where we're going to start solving problems using this rule. So thanks for watching and see ya.